time, right?
Yeah.
Okay.
Let's see. No, cannot.
You cannot see it? It's here, it's okay. Okay, thank you. You don't see it?
I think it's live.
At least it shows here. No, as I can see online, okay. So, hello everyone. I'm Jérôme François, co-chair of NMRG, and this is for the NMRG session. The other co-chair, Laurent Ciavaglia, is online and cannot unfortunately join the meeting on site. With me, just at my left, this is Jefferson Campos-Nobre, who is secretary of the group as well. So let's start the meeting, and with the first of all, of course, the notary regarding intellectual property. So you must know that the IETF follows the IETF intellectual property right disclosure rules. So you can here read the different rules. Which is important to note is that if some contribution you would like to share that are covered by a patent or application of a patent, you should disclose it before in a timely manner. Of course, here you have the reference document that I invite you to have a look if needed. So important information regarding audio and video recording. So as you may notice, there will be a recording which will be done that includes audio, video, and photographs, and those will be published online. Of course, you can have this red "Do not record" lanyard. So if you do not wear it, you consent to appear in such recording. And of course, if you speak in a microphone or if you even online, or if you put your video online, either on site or online, if you speak in microphone, you also consent to be recorded. So this is very important. So if you're online and don't want to consent, you must turn off your camera and microphone, basically. So although here you have some other reference, in particular that personal information that you provide to IETF will be handled in accordance with the privacy policies that is shared with you here. As a participant, you agree to work respectfully with other participants, and so please contact the Ombuds team with the link here if you have a question or concern about it. And we recommend and we ask you to look at the RFC 7154 and RFC 7776, which also apply to IETF. Just also a reminder about the goals of IETF. IETF conducts research. It's not a standard development organization. So the IETF focuses on longer-term research issue related to the internet, while the parallel organizations, the IETF, focuses on shorter-term issue of engineering and standard making. While the IETF can publish informational or experimental documents in the RFC series, its primary goal is to promote development of research collaboration and teamwork in research issues related to internet protocols, application architecture, and technology. Another area of the RFC 7418 that refers to that. Here's a link for the meeting. What is important and what is, I think, written in the slide is that even if you're on site, it's important that you connect to Meetecho, because this will be necessary to collect the blue sheet. It will be done by this way. So very important that you connect also to Meetecho if not done yet. You have here the link for notes. So that will be also used afterward the meeting to also create the minutes. And of course, all materials are online as well. So let's move on now more to the content of the meeting. So there will be a brief introduction here regarding the status of the group. So from the last meeting that we had, basically there are the two RFCs that was in the queue regarding IBM that have been published. So the first one, which is RFC 9315 about intent-based networking concept and definition, and RFC 9316 about intent classification. Although there is one active research group document, which is about digital twin network concept and reference architecture. Although there is a bunch of documents which are run in the group for, let's say, for a while, quite stable, and maybe there will be, for some of them, for one of them, there has been a call for adoption before, but we think also as the chairs of the group that there will be potential upcoming call for adoption for this document listed here. The first one about network measurement intents, the other one about IETF network slice intent, and the last one about interconnection intents. The question also, because these documents will be presented today, the question will be how will they evolve towards having this document adopted and maybe and then to pursue for possible publication as RFCs to have a single or multiple use case documents. This question is still open. And although the other documents that are possible upcoming call for adoption will be about the research challenges in artificial intelligence for network management, there will be an update presented today as well. Although we would like to also like to share with you the maybe to recall the research agenda of NMRGs that you can also find on the data tracker. One major work item of the group was related to IBM. As you know now, we have the two RFCs that has been published. We have the use cases, and the question is that would, as a group, if we want to pursue this work on other, let's say, work item, for example, architecture or not, it was initially the objectives, but after some meeting, there was no so much content about that, but it's still open, and so we'd like also to have your feedback regarding that in the discussion. Of course, there are kind of rather new topic in the group, like the AI, network digital twin, and more recently, green networking. So also the question will be, should this different topic continue to be part of an NMRG? Should be somewhere else for them? Is the NMRG the right place for this topic or not for future works? So the questions that we are currently think are important to ask ourselves as a group as well. Oops, sorry. And so here's the agenda for today. After this short introduction, we will follow this with, let's say, 4 groups. The first one about IBM, the second one which is about AI, the third one about network digital twin, and the first one which is more open, or let's say prospective, at the end of the meeting. And that's all for me. I don't know if Laurent, you want to add something from your side? Okay, nothing to add from Laurent. So also if there is no comment or question, I propose that we move forward. So I just request different speaker to keep track on time as well, and I will try to use this countdown stuff on the meeting code to help you. So let me ask Luis to start presenting. I will just share the slide. I think the first one is network slice intent. This one. Yeah, for speaking, can remove.
Okay.
Just let me know when you want.
Okay. Thank you. So hello everyone. I will present one of the two use cases for intent. This one is related to the network slice intent. So next, please. So as a reminder, the idea would be to leverage on intent-based network technologies for requesting IETF network slices. So the use case, one of them could be so an upper system is requesting a slice and to the IETF, let's say, capabilities, the IETF network slice controller, and this very immediate use case could be the 3GPP management system, for instance. We will comment later on the idea of a POC on this respect. So essentially, through the intent, we will have a declarative intention of a slice, and this declarative intention will be translated to, we expect to be translated to a kind of an MBI that could be supported by an SDN controller, an IETF network slice controller, and so on and so forth. So the benefits of going in the direction of intent-based will be the portability. So we could have a solution that could be consumed by different implementations later on in the control part. Also a simple way of expressing transport slice needs. So a declarative way of expressing the slice needs, the SLOs and so. And as any kind of intent system to focus on the what and not on how, right? The how will be later on being decided by the IETF network slice controller in this case. So we see this as a complement for the working group, for the slice work in this working group. So complementing all that stuff, all those ideas of network slice controller with an intent-based system on top of that for doing that translation from the declarative idea of an intent to the normal interface of the network slice controller. So next, please. So the updates for the latest version, essentially we added, we restructured section 3 by adding a new subsection with the targeting, let's say, additional information needed for a network slice on the IETF domain. So essentially we have taken what is being working out in this and trying to, let's say, make consistent also the intent that we could declare in the upper part in order to do an easy translation from the declarative slice intent towards the MBIM model. And also we have provided details on the assurance phase of for the intent lifecycle. So as you can see there, in the previous section, we propose the fulfillment part. So we are here complementing with the assurance part. We have on the monitoring side the collection of monitoring information related to the slice. So whatever has to deal with SLOs and SLEs that are expected for the slice. In the middle part, we will have the aggregation of this information, this monitoring data that could fit the validate component that will help us to realize the inner closed loop for controlling the intent in the provider side. And also on your left, you can see the components for providing the report to the customer. So somehow abstracting the monitoring information, the monitoring and telemetry information in such a way that the customer can receive feedback from the behavior of the slice, and then the customer can perform the outer closed loop for fixing whatever problem that could be with the slice. So next, please. As next step, we are targeting a POC. So essentially, we understand we have, let's say, like 5 main components to address. The first one will be the translation from this upper system. So taking into consideration the information that could come for, in this case, in this particular example, from the 3GPP system. So understand the kind of objects that a 3GPP system can propose to the intent-based system, so taking them and translating them. This would be the component 1. The component 2 would be essentially the mapping to the node-bound interface of the network slice controller. So for that, we are also running some parallel work in this working group. We have I have put there a couple of drafts. The first one in the upper part is essentially, we intend to describe there the mapping of the information from 3GPP to what would be the MBIM model, and the one at the bottom is essentially the realization with current IP and PLS technologies. So the idea is to leverage on those drafts for, let's say, accomplishing the fulfillment part. For the assurance part, that will correspond to component number 3. The idea is to leverage on some other work in IETF, maybe the service assurance architecture that is being proposed in OPSO. And then we will have the component 4 and the component 5. The component 4 essentially will be to report to the 3BB management system the behavior of the slice, so reporting some KPIs essentially. And the number 5 will be the validation of those KPIs for performing the inner close loop, control close loop. So next, please. Well, sorry. the question, I put also this question maybe for discussion, if we should document fully the use case in this draft, or essentially pointing out to other working teams and so. So this is a question maybe for discussion. Next, please. So key questions from the chairs. The chairs propose us to answer a number of questions. So the objective of the work was one of them. So yeah, this is clear. Our intention is to elaborate intents that could facilitate the request of IETF network slices. So complementing therefore in this working group, defining a suitable internet-based system for consuming IETF network slices. Regarding the remaining steps to finalize, essentially we need to propose a structure to express the IETF network slice service and validate them. And the idea is to validate through the POC. And taking as an example the 3GPP, which is the more mature. And how long this would take? Well, the idea is to do this proof of concept for the fulfillment phase, the component number 1 that we saw on the slide before, targeting April 23, hopefully maybe the IETF115, but probably it's too soon. So will be probably more in between if we have a kind of interim meeting or so. And then the idea would be to start working on the assurance phase, probably with a basic approach, not very much sophisticated, and maybe targeting the latest IETF meeting next year, IETF 118. With that, we would have the outer closed loop, more or less, or some kind of proof of concept in that respect. And trying to work on the component 5. This is for further analysis. Probably we need more capabilities, maybe leveraging on artificial intelligence. I don't know. We need more time for analyzing that. So next, please. And this is the final one. So we need to define the structure of the IETF network slice intent template and how to do this declarative approach. And then address the fulfillment phase, so elaborating on translation approaches and interaction with the upper systems, and the assurance phase for exploring the monitoring, telemetry, all the data that could enable the interaction with the customer and the control closed loops. And that's all from my side. Thank you.
Thank you, Luis. There's a question online. So there is a question online on slide 12. Is tagging an intent as SLO or SLE part of the intent formulation itself, or is it part of the translation process?
So could you repeat, please?
On slide 3, is tagging an intent as SLO or SLE part of the intent formulation itself, or is it part of the translation process?
The SLO SLE will be part of the translation process, because could be the case. I mean, what the network will be able to manage are SLOs related to the network, but we are not so sure what could be the kind of, the SLOs from the perspective of the customer. If we take the 3GPP example, probably could be similar. We could be talking about network SLOs in every case, in the customer side and in the provider side. But in general cases, could be the situation that the customer expresses SLOs related to the service. So how we need to translate these service SLOs to network SLOs.
Okay. Thank you. Yes,
So this is Alex Clem, Future. So I think this is a very nice use case, so very nice topic. But I do have one question concerning NMRG versus standardization. So the question is basically, how much do you think is a research type of agenda versus how much might be ready for standardization? You're talking about the Yang model, which would be an IETF and so forth. Can you perhaps comment?
Thanks for the question. Certainly, there will be aspects more related to research. For instance, all the control loops. This is probably more focused on research. The pure translation itself is not. There is not so much research in that respect. Maybe there could be areas, as we commented just now, the translation from service SLOs to network SLOs, so some ideas of how to digest, let's say, the service expressions to relate, to transform to network expressions. Maybe that could be much more related to research. The pure translation itself probably is not research at all. Yeah.
Thanks.
I think online, Laurent has a question.
Planning to be aligned with, let's say, TMF intent model or intent API, or are you planning to start from scratch?
Well, the idea somehow is to offer the intent in a general manner. The relation with TM Forum and some other APIs on top is not, I mean, probably could be even on top of the upper system that will request the network slice. So maybe not direct, could be that there is no direct relation between the TM Forum APIs and the IETF network slice stuff. So somehow the idea is to offer a mechanism for that translation that could be consumed maybe for the TM Forum or for some kind of component between the TM Forum API and the IETF network slice controller.
Okay, so thank you, Luis. I think there is no other question. Laurent has some audio issue, so we'll probably take offline the question, so we can move to your other presentation. With the interconnection intent.
Okay, so this second case is about interconnection. So next slide, please. As a reminder of the motivation and the objectives, the idea is that somehow we are now in a moment transitioning from the classical interconnection, which is simply the interchange of IP traffic, to something much more sophisticated, which requires to provide, to request capabilities related to service functions, to network or compute resources. So moving from the simply interchange of IP traffic. So a part of IP prefixes, so the idea would be to interchange or to request in that interconnection intent, service functions, network compute resources, memory, CPUs, or quotas, or whatever. So next, please. So as a summary of the draft, also as a reminder, so the idea is to leverage on intent-based technologies for handle this enriched interconnection. Scenarios of applicability, we listed there a number of them, but could be others for sure. Could be the interconnection of non-public network to public networks in 5G, or multi-domain network as a service request, as in section 4.4 of RFC 8568, or multi-domain network virtualization, like in the draft that I referenced there. There could be others as well, for sure. So the modes of usage of this interconnection intent, we can just simply stay with the IP traffic interconnection. I mean, the classical peering and transit, the business as usual, but we can go further. Probably requesting services such as the CDN interconnection as defined by IETF CDNI, or a virtual network function as a service. So, for instance, requesting packet core network capabilities for mobile virtual network operators, or compute capabilities as we propose as well in other draft from this working group, or any combination of all of them. So essentially, as said, moving from the classical IP interchange to something much more sophisticated. The benefits, as before, would be to establish a common and normalized way of doing these enriched interconnections and a simple way of expressing them, and also having portability, let's say, between implementation later on in the control part. So next, please. Updates from the previous version, we have added details on assurance phase, as was presented before in the case of slicing. I will present it in the next slide. And also we introduced some insights on interconnection intent structure. So information about the type of data traffic to be interchanged, service functions expected to be supported by the peer provider, resources expected to be offered by the peer provider, constraints that could apply to the traffic steering or to the resources that we are requesting to the other provider, or even the chain between the functions that we expect to be accomplished in the other provider, and whatever additional information that could be necessary for delivering an end-to-end service in the other provider side. So next, please. This reflects the detail of the assurance phase. As before, we will have the part here on your right for monitoring and collecting the telemetry data. Then in the middle, the idea of checking that data for either validating and performing the closed control loop internal to the provider B, in this case, to the provider that is peering with the requester. And also we will have on your left the capabilities for reporting, analyzing the metrics of the interconnection, the enriched interconnection, and then triggering corrective actions if needed that would implement the outer control closed loop in this case. So next, please. The key questions that were asked by the chairs. So the objective will be to elaborate these intents to facilitate new interconnection needs, sophisticated needs, service functions, resources, and so. The remaining steps for finalizing this, the idea would be to propose a structure for the intent and then to validate it through a POC. And regarding how long this could take, we could foresee a POC targeting the latest IETF meeting next year, and maybe could be even a potential topic for a hackathon at that time, because whatever has to deal with interconnection has to deal with interoperability. So it could be maybe a very good topic for having interoperability in the hackathon in IETF115. So next, please. For moving forward the draft ideas, the idea will be to define in more detail the structure of the intent, the template, the model, to model, let's say, the objects for interchanging between the peers, and to identify protocols or APIs or the lack of them for accomplishing the different kind of interconnection types considered. So not only IP traffic, but service function, resources, and so on so far. So the feedback is more than welcome for sure. And there is just one remaining slide, Jerome. Because this is a question for the research group. We have been in contact with the authors of the measurement intent, the colleagues that will talk after me. And we have common interest in the drafts of each other. So we have two options for progressing the work, either combining the two documents or even, the authors of each document joining the other document. So this is a question for you, the chairs, and for the research group, what could be the best way to follow, okay? And that's all from my side, thank you.
Thank you, Luis.
Hi, Luis, Dhruv here. Luis, in this, is the provider network and client network interconnection also part of this, or is it only related to multi-domain provider network interconnection?
The original idea was the multi-domain provider to provider, but could be probably easily extendable to the client to provider. I do not foresee any problem in that respect, but the original idea is provider to provider.
Why I bring this up is during the IETF network slice discussion, there were this talk also about, like, I might need to create more logical interfaces as I move things, and I would like to do it in a much simpler way. So I think what you're proposing here could be used even for doing that. So it might be worth expanding it a little bit and including that as well.
Okay, thanks, Drew. Thank you.
So there is a question online. So Trev, you can ask your question.
Was already done. Was Drew?
Oh, I think he left the queue. Sorry?
Who's Drew?
Okay, I'm sorry. Didn't get the name. So for maybe as a chair for a question, I think for the two options that you are mentioning, I think it's hard to give you an answer like that. Maybe it should be good that with the other author you show what are the common part, maybe in another meeting, what should be merged and what should be in common to figure out exactly what would be the merge.
Okay.
Because it would be, I think in general we say it's if there is a lot of community, it's good to merge. If not, maybe not, but we should see, because it's for me at least, it would be hard to take a decision just by these two questions.
Okay. Thank you. Okay, thank you.
So thank you, Luis. So let's move on to the next presentation. I think next speaker is Dan Yang.
Hi, Chair.
Can you hear my voice?
Oh, okay, you will present. Okay, I will just share the slide and then. Okay.
Hello, everyone. I'm Ke Yao from China Mobile, and this time I'll present about AMI network measurement intent. Since two working items have been published as RFCs, namely the concepts and definition of IBN, classification of IBN. So I think in the next step, there is a need focus on studying the use case of IBN, what exactly IBN can bring in what kind of scenarios. So that's basically why we propose a typical use case of IBN, network measurement intent, which we think is a very important and practical use case of IBN. And after several updates of the draft, we have received very valuable suggestions from Giuseppe and Chen from Huawei and Luis from Telefonica. And we all think that NMI is well worthy of studying in NMRG, and we are looking forward to more suggestions. So next slide, please. So here is a very brief recap of the draft and the recent update. So the introduction about NMI, NMI is to use a network measurement intent to achieve network performance aggregation based on user or network administrator intent to verify whether a network measurement result meet the measurement intent and further improve the accuracy of the configuration in the network. So, and this time we have make a update of the relationship with two RFCs, that is the concepts and definition of IBN and the classification of IBN. So next slide, please. And in our proposal, we further divide NMI into different subgroups and from different angles. And in concrete examples, we have listed about time accuracy measurement, which is about how to balance and accurately measure the network state from the time scale. And we also list about the use case of spatial accuracy measurement, that is to measure the network state, but at the same time to take care of the network resources to reduce as much as possible the resource to be employed in the network, that is to achieve at the meantime to achieve the desired accuracy. And also we have listed the classification of NMI, that is a static NMI and a dynamic NMI. Static NMI is about the measurement purposes remain unchanged and is independent of the network state. But dynamic NMI is changes dynamically according to the network state environment. So these are the brief recap of the draft and recent update. So next slide, please. So after the last time, the calling for adoption procedure, we have received about a total of 9 members from different entities to support the draft. We have solved the questions raised in the mailing list, and we have updated the references of other RFCs and the working group documents. And next slide, please. So for the next step, just like Luis mentioned in his draft, interconnection intent, so different personal drafts focused on IBN use cases have been proposed to NMRG. We can either merge them into a whole working group document of IBN use case. Alternatively, we can update separately and join each other. So, and this time we still hope to receive comments on this draft from audience and chairs, and we hope to push forward on the study of IBN use case. So thank you very much. Looking forward to questions.
Thank you. So any question from the audience? Okay, so maybe for again, this is a bit similar to the question before about the merging of drafts. If I understand well, there is still this, as I said in the introduction, this option for merging to have one single document for all even use case or not. I think maybe also Jefferson, you can pick about that. I think this is still open. The main, let's say, concern will be that to identify a common structure and template. I think Jefferson started to do so, and then maybe it's also a question to all these authors working on use case document if this structure is okay, or they would like to change it, or maybe they see that it will not be possible to have a common use case or a common document. It will be just let's say. A sequence of document to document that will be not good. So I think it's very important to, of course, to identify what will be the structure of such a document before saying that yes, we will need a single document on it. I don't know if you want to add something, Jefferson.
No, I think that maybe if because we had this template for the document, so if the authors of these drafts can address that, like saying that it's okay, or we can maybe change the template, I think it would be nice. Otherwise, in the next meetings, we can have presentations pointing out the similarities, like to show if it's possible, at least, because I think I also agree that it would be better to have just one document, but we will have to see if it's possible.
Thank you, Jefferson. So
Thank you, Chef.
Yeah, thank you, Akad. And so we'll continue with the next presentation. So that will be given by myself. So just ask you to change the slide. Just open the. Just yeah. Okay, so I'm Jean-François. So this is a short update about this slide regarding research challenges in coping artificial intelligence and network management. Next slide, please. So here's again just a summary of the outline of the draft. So maybe just as a remaining, this is that's the second version. But of course, if you remember, if you're participating to the group before in the discussion, we have this shared document that you worked on before it was in the format of a draft. So here's the current, let's say, outline, and just also as a reminder, so I have basically three main categories to classify the challenge. We have challenges relating to the AI technique for network management. We have one, which is section 6. Section 7 is about the network data. It's like common problems that you have when you want to use AI. Section 8 is more about the acceptability of AI itself when we apply it to our domain network management. Next slide, please. So from last time, we received a few comments. So we basically changed the document according to them. We complete the document to cover some issue or some concepts that were not covered well. In particular, we refer to the data mesh concept. I think rather than the concept, what was very interesting to highlight here is that in the previous version, we highlight that there are different granularity of data, there are different volumetry, different dynamicity in the data that come at different time and so on. One important thing that we did not really highlight is that, okay, there are different types of data by their nature and by their way they are provided. But when you have to aggregate these data, they might not be aligned in terms of time as well. And this can also raise some issues and challenges. So it's not just only we have real-time data or we have data that arrives very fastly. Some can be very fast, others are not. And so sometimes we need to still align them. Next slide, please. So for the next step, what we would like to have is, of course, have more feedback from the group, and also maybe have a call for adoption that we would like to ask for this in the next step. We have already identified possible addition. We don't know if we need to include already then or if we need to include at all. Regarding lightweight AI within distributed AI, it's not well integrated now. There is some discussion about the impact of labeled versus unlabeled data. Also, there is some discussion. I mean, internally between the, let's say, the group of authors about having some more content about the legal or regulatory part of, let's say, using AI for network management. What we think is that we cannot be exhaustive anyway, so we try to figure out what would be the most valuable challenges for the group in the documents that we put. Of course, all your feedback is welcome to be sure that, not that we are not forgetting something, because I think it would be very hard to be anyway to be exhaustive, and might not be the call here. And also an additional next step would be that know that we have this document that is, we think that is quite stable. So let's see what is your feedback as well, of course. What would be the role, as I chair, as I said, the beginning will be the role of the group regarding the different challenges. Okay, so maybe we are happy, we have a nice document that you can refer in different papers or other drafts and so. Would be also the objective of the group to more deeply investigate some of the challenges by providing some solution. Maybe not all, probably because there are too many. Or do we try to maybe simply try not, if you are not, let's say, providing solution, try maybe another possible approach would be try to identify and maybe some kind of list what has been proposed in literature and so on to solve these challenges, at least partially, to just also, other than just purely, we have already references of course, but rather than purely just the challenges, maybe some kind of, let's say, living document where we say, okay, there is new solutions that being proposed, I don't know, here or in this conference or by this tool and so on, so that can fulfill the challenge and can be also a goal of the group to maintain this as well. Of course, maybe in some I see more, let's say, drafts which are more focused on certain challenge, and that's why also send you a presentation about that. And that's all for me. So if you have any question or comment. Yes, Laurent.
Another question.
Are we waiting for Laurent? Or?
I think he, I see the icon. So, but maybe ask your question because I think he has maybe some audio issues still.
Well, I forgot to click the button. This is Diego Lopez. When you're talking about the data challenges, etc., I miss a couple of things. One is the suitability of unsupervised environments in networks because of the stability concerns and all the like. This is one thing. The second, and I believe is something that is critical in the application of AI to networks, is precisely distributed AI, or not only the federated models, but anything that is implied by the using localized AI and knowledge sharing. Just if you want to add a few other subsections to the document.
Yes. So yeah, I think this will be important to have it as well, right? This is the message.
Yeah, no, I mean, if we're talking AI and networks, there are a couple of aspects that I believe are essential. Just
yeah, we think so. That maybe what was missing, at least maybe in the group of authors, somebody that is really, let's say, distributed at what is so let's say trendy today with the federated AI. You are looking for some help. So if you need the room is volunteer to help us for this part in the document, we'd be very happy to have it on board.
I think I could try to make something if you don't mind.
Because we try to figure out who could contribute with the right.
Okay. I'll try to prepare something and share with you.
Thank you.
I think Lohan is on the queue, but no. Lohan, can you speak?
Maybe he has some audio issue. Okay. can maybe
Yeah.
bring it forward. At least maybe put on the chat.
We can proxy your question to Jérôme if you write on the chat. He's having some audio issues.
Yeah, yes, some audio issue. Okay. Yes, please. So let's continue. Yeah, yeah. Oh, yes, I keep mine. Let me share.
Okay, good morning. My name is Yong-gun Hong. I'm working for Daejeon University in South Korea. This is the Internet draft. The title is Consideration of Deploying AI Services in a Distributed Approaches. Next page, please. Okay, this is the second version and second presentation. Okay, next page. Next page, please. Yeah. This is update after last meeting. So we reconfigured the section 4. The section 4 title is Consideration for Configuring a System to Provide AI Services. So because we found on one the relevant reference, that is the ETSI document. So based on the idea, we subdivide the section 4, the section 4.1, section 4.2, and section 4.3. The section 4.1 is to the functional characteristic of the hardware, and section 4.2 is the characteristic of the AI model, and section 4.3 is the characteristic of the communication method. And we add one reference, that is the ETSI document. The title is Mobile Edge Computing, Market Acceleration, MEC Metrics, Best Practice, and Guidelines. Group specification, ETSI-GS, MEC IEG 006, but 1.1.1. And we invite to export from ETRI. Next page, please. Okay, this is the motivation of this draft. Previously, the chair present the challenge document. So based on, we are investigate the development of AI services, because now the focus is moving to training to inference, from learning to prediction. So, you know, for inference, not only high performance server, but also small hardware, microcontroller, low performance CPU, and AI chipset are the optimal target device. The reason is to, you know, the cost. So we are consider the computation of the system in terms of AI inference services, not of training. So if we think about for training, the main important thing is the accuracy of the model. But if we think about for inference, not only accuracy, but we must consider other items. For example, target device, objectives, and the consideration others. For example, if you think about target device, we can choose a local device, edge device, or cloud server. And if we find or judge the objectives of the AI model, it can be diverse. For example, accuracy, latency for real-time services, and network traffic, resource utilization, etc. So I found some consideration for the system for AI inference services. One is the AI model, and the other is serving framework, communication method, device capacity, inference data, etc. So the last sentence is the main purpose of our draft. We want to accelerate the study AI issue and find some possible standardization items in the MRG. Next page, please. Yeah, so you know, I guess you are familiar with the generic procedure of AI services. The first one is data collection store, and the next stage is to data analysis, pre-process, and the next stage is AI model training and AI model deploy and inference, and the final stage is monitor and maintain accuracy. So in our draft, we are not targeting on the training AI model, but we are targeting on the first and the last stage.
that is the AI deployment and the monitor and maintain the AI service quality. Next page, please. Okay, so we can make a network configured structure to provide AI services. The first one is the AI inference service on local machine, and the second one is AI inference service on cloud server, and the last one is AI inference service on edge device. Next page, please. Also, we can combine between the edge device and the cloud server for load sharing or task offloading issue. Next page. Yeah, this is the main part of our draft. So the first, the consideration is to functional characteristic of the hardware. So in the ETSA document, so it describes various metrics which can be potentially be improved through deploying a service on a MEC platform. MEC means the mobile edge computing. So it can be identified in order to highlight the benefit of deploying MEC for various service and application. So the first is the functional metric. It includes latency, energy efficiency, throughput, good food, loss rate, etc. So in the other metric is non-functional metrics. It includes service life cycle, service update, etc. So I guess that if possible in the MRG, we can follow this the approach to find the relevant metric for the AI deployment services. Next page, please. Yeah, so you know the performance AI inference service is varying depending on how the hardware such as CPU, RAM, GPU, and the interface is configured for each cloud server and each device. So in the distant cloud server, it is the high performance and high cost. In the near edge device, it can be medium performance and medium cost. In the local machine is the low performance and low cost. But if we have some assumption, if you use the same AI model, so in the distant cloud server, it provides high accuracy, short inference time, but it has a long delay to transmit. Near device service, it provides the medium accuracy, medium inference time, and the medium delay to transmit. In the local machine, it provides low accuracy, long interrupt time, but it has the short delay to transmit. Next page, please. Yeah, so we can sum the figure from the Google TensorFlow. It shows the trade-off between model size, accuracy, and latency. As you can see, we can find the optimal model if we choose the model size that we can must keep up other point of view. Next page, please. So it is the characteristic of the AI model. So usually in a cloud server, we deploy the heavy AI model. It provides high accuracy, but it has a big file size and it has a long inference time. In the edge device, it provides medium AI. It utilizes medium AI model and the medium accuracy, medium size, medium inference time. And in local machine, usually it utilizes lightweight AI model and it provides the low accuracy, but it has small size and it has the short inference time. So as you can see, there are trade-offs, the accuracy and the model size and the inference time. So we can choose the best one according to the service requirement. And the AI inference serving framework is a kind of the implementation issue. We can choose between traditional web server, for example, Fast API, Flask, and Django, or we can utilize specialized serving framework, for example, TensorFlow serving. Next page, please. So, and also, if we think about the characteristic of communication method, we can choose two kinds of the communication method. One is the traditional REST method, and the other is the specialized communication method, for example, gRPC. And we also consider the AI inference data, which is the real-time requirement, or it is the batch-style services, or it requires the secure, or it requires non-secure. Okay, next page, please. So it is some example of our the prototype. So we made some the POC based on our draft. Next page, please. So it is some kind of the results of the object detection services and local machine, edge device, and cloud server. Next page, please. So I also request to the chair to share our opinion for the relationship to challenge document. So I believe that the challenge document is the main document for handling AI issue. So our draft is also related to the challenge document, and some text can be added or merged. For example, distributed AI services, lightweight AI service, and deployment AI services. Or we guess that our draft can be deployed as a different document to focus on AI inference, deployment AI services, because the existing challenge document include many items, so we can focus on some the specific area. Okay, next please. So that's all, thanks.
Thank you. Any question, comment? Yes, Alex.
This is Alex Klein, Future Way. Yeah, thank you for your presentation. I do have a question / comment. I'm wondering actually how much your draft is really more about system management versus network management. A lot of the challenges that you've described seem to apply more, okay, what do I have on the server, less what's on the network. For instance, also some related challenges to deploy, for instance, things like federated learning or transfer learning across the network and so forth. I think these are somewhere where some of the real challenges also lie in that space. And I don't see them mentioned in your draft. So I'm wondering, do you see the focus more on the network or on the system side? And I think my comment is I would like to see a little bit more on the network management side.
Yes, you're right. Thank you for your good question and comment. Yes, you're right. In the current document, it really focusing on the system point of view. But in the NMR and in the IETF, we are finding some the network point of view. So this is our homework. So we will find it to revise in the next version to include your point of view.
Yeah, so I think I would have some suggestion to
definitely
to add. Thanks.
Okay.
Jeff Kinsler, Microsoft. Thanks for the presentation. So you've been talking about vertical hierarchy, far, mid, local.
Yeah, that's right.
However, the horizontal hierarchy is probably even more important here.
Yeah,
so whether you are capable of running your job on one machine or endpoint or GPU, or you need to distribute it, what do you do with network computing, with collectives? It has much more severe complications than going far. Maybe less for inference, more for learning, but still would be really good to see.
Yes, you are right. So in our experiment, we have the similar approach. We have the multiple edge device. So take the task offloading and find some the optimal way how to do. So yes, you are right. We can not only vertical area, but we also find the horizontal area for the distributed approach.
Would be good to see more text. And
okay, thank you. I find it next revision.
I have a comment. Jefferson Nabe Urgs. I think it would be nice to have pointed out the similarities that you see among the documents, like the one that you presented and the research challenge, in order to see, how big are the difference between and what can be merged. So it's more like a comment.
Okay, thank you. Thank you very much. So we can continue. I think we're right on time. So I think next speaker is online. It's Chris.
Good morning. Can you hear me?
Yeah, we can hear you. I don't know if maybe you can speak a bit louder. It was a bit.
Oh, okay, I will try.
Okay, yeah, it should be okay. Thank you.
Okay, thank you. Good morning. My apologies for not being there in person. This is a first revision to a draft introduced at the Philadelphia meeting. The topic is performance-oriented digital twins, now for carrier packet and optical networks. Next slide, please. So the original draft introduced the concept of a performance digital twin for carrier networks, so-called network digital twin. This draft generalizes the concept of a performance digital twin. So we introduced the term performance-oriented digital twins. It reframes the originally presented NDT as something specific to packet networks and introduces an optical performance digital twin, OPDT, that's something specific to optical transmission networks, as a second example of PODT. It considers use cases for the OPDT, and there's significant congruency with the use cases presented in the original draft for NDT for packet networks, and also talks about architecture, interfaces, etc. Next slide, please. Okay, so again, going back to the first draft, the performance-oriented digital twin, the idea is to predict or replicate, pick your verb, performance behaviors of a physical network. Of course, the particular behaviors of interest are determined by use case requirements, but they must be rendered by available and appropriate functional models. We introduce here the notion of a so-called network information interface, NII. This is optional or present case specific, and it's really a twinning interface. It's where we can absorb data from the physical network and or management plane about the network services, traffic, environmental conditions, what have you. Really, all the information we would require to construct on an ongoing basis a faithful replica of a physical network. The digital twin interface, as previously defined, is a runtime interface, and we can conceive of the inputs as defining the scenario for behavioral assessment. And so in that sense, they would select, replace, or complement data present at the NII. The outputs, of course, are modeled behavioral parameters. And in the interior of the PODT, congruent with the notions described in the architecture document, we have data, we have models, we have interfaces, and we have management of all of these components. Next slide, please. So the DTI, the inputs, as I'll show, they depend on the use case. The outputs for the OPDT really are optical channel parameters, so path terminating channel powers, and particularly things like generalized signal-to-noise ratios, margins, things of that nature. At the NII, from the management plane, we would get network and service topology. These are provisioned networks. And of course, IETF defines a host of relevant models and frameworks, ACTN, abstraction and control of transport networks from TEAS, and related Yang models from other working groups being fit for the purpose. From the physical network, inventory, device parameters and status, instrumentation, data, things we measure on the network, alarms, etc. And we would conceive of these normally as coming through the management plane, but that's an implementation matter. Behavioral models, things like we have to understand given transponder parameters, modulation, baud rate, etc., back-to-back channel performance, things like amplifier, gain and noise models, nonlinear impairments, polarization dependent loss, filter shaping, etc. Next slide, please. So a quick look at use cases, and of course planning was a major category of use case considered in the first draft for packet networks, and we have corresponding planning manifestations in the optical network case. One of them is optical services planning. So if we're looking at introducing or provisioning a new service or some batch of services, we need to go through a planning exercise and figure out the route and spectral allocation, but potentially also transponder parameters in the case that we have tunable transponders. So the DTI inputs are, of course, the channel parameters postulated and a postulated service topology. And really the OPDT then is returning the channel performance parameters. It's identifying channels that would have negative margins or be non-functional. So obviously those are solutions that would be prospective solutions that would be discarded. And basically the findings are used to guide a search for service solutions that possibly are also efficient in some sense. So the possible embedding of optimization is described in the original draft. Important to note that the OPDT doesn't operate that search. It merely provides information to it. Optical network planning, basically the same thing, only we're looking for conjoint service and network solutions that are both functional and now certainly efficient, for example, in the sense of some lowest cost of network. And in this case, the DTI inputs would have to encompass both service topologies and channel parameters, and also the new or modified network topologies being postulated. Next slide, please. Optical services reprovisioning. So this is in support of active operations, add, drop, reroute, for example. Before executing such a change, we would want to assure that the post-change state is entirely functional. So we would conceive of some algorithms looking for batching and sequencing of operations, power optimizations, etc., that will lead to a successful reprovisioning. And of course, in that search, the OPTT can function, can assist by looking at the functional integrity of all of the postulated service state steps. There's the possibility of risk mapping to look at any prospective event scenarios and identify potential transmission performance issues. For example, we can look at prospective fiber cuts, examine our planned restoration responses in those cases, identify possible performance risks, and where such risks are identified, we can construct new planned dynamic restoration responses. And of course, that whole process can be automated as a closed loop. Next slide, please. And I'll just close with one sort of more abstract thought. This digital twin we've described is what you might call an information digital twin. It provides information given data, but the use of that information is left to, it's a service and whatever the consumers of that service happen to be. You can conceive of, and some do, a larger sort of sphere of action of a digital twin. Imagine ingesting intent and issuing network control outputs. Such a conception, though, obviously encompasses full closed loops, not just data to information, but information to decisions and decisions to action, right? So this is a collection of functions, not a single function, but necessarily including the information digital twin described as one. And such a larger scope of function, frankly, starts to become difficult to distinguish from a management plane featuring automation as a whole. So you just throw out the question, perhaps one suffices as a general conception of the functional scope of a network digital twin. All right, that's it. Thank you.
Yeah, thank you. Okay, so there is a question from the queue from Sharon.
Yes, hi. Thank you for the presentation. Very interesting. I wanted to ask, did you consider making digital twins of the traffic patterns on a granular flow basis, meaning a digital twin of a subnet or a group of users to detect anomalies, potential lateral movements, basically IPFix based twins?
Yeah, so I mean, that kind of thing was considered in the first draft in the NDT dealing with packet networks. It's not relevant to the optical performance digital twin, right? I mean, there we're dealing with provisioned optical paths. But I think if you go to the draft and look for the content specific to the packet network performance digital twin, you'll see thoughts related to that. And it would be something that the first set of authors would probably speak to better than me.
Thank you.
And just
I see Jordi has his hand up, so he may be able to.
Yeah, there is a question also in the chat from Laurent. Maybe you take this first, as it was first. So do you consider the configuration type of interaction on the NII interface? For example, to configure collection, measurement, monitoring information flows to the PODT, or is this configuration indeed at another interfaces or by other processes? You can see the question in the chat as well, Chris, if you want to answer.
Yeah. Sorry, I'm just. Okay. Just want to make sure I understand the question. So first of all, the function of the performance-oriented digital twin, it does not issue control or configuration outputs, right? It provides information to processes that may or may not do that. I'm not sure if that was the sense of your question, but to be very clear on that point. And that's really what I'm getting at in this last slide. The conceptions of digital twin that float around. I mean, if we look at the architecture draft, right, we defined as interfaces, models, and data, and then something to manage those together. What those provide is information, right? To provide action outputs or to ingest intent, you need more functions, right? And ultimately, to issue action on the network, you need full closed loops. So in our conception, that's a larger set of functions. And again, it starts to become pretty much what a management plane as a whole does. So it gets a little bit tricky intellectually in my view. For the interfaces themselves, again, the idea is that we have a so-called twinning interface that is the steady receiver of information about the physical twin. And of course, in some scenarios, there may not be a physical twin, right, if we're looking at greenfield planning. But in general, the idea is that there is a physical network that we're trying to replicate as closely as possible. So the idea is that the NNI is the source of that real network information. Of course, on a provisioned network, the service topology, for example, that's something that's controlled and understood by the management plane. So that would be the source. Hopefully that answers your question.
Okay, thank you. Maybe you can take the question from Alex in the room and then Jordi.
Yeah, so this is Alex Clem. I just have a comment on what you put here on the last slide. I would assume actually that the second one is the more general conception. The first one is more restricted, right? Because I mean, there you're committing to who your golden twin is, so to speak. So I think it's more interesting to look at also number two, which includes number one.
Yeah, and I understand that. I wouldn't want to rule it out. I'm simply pointing out that, the definition two, first of all, it's not a single thing, right? It kind of follows the use cases, and therefore the components and functions that are involved are variable. And the other thing I notice is that, well, it starts to look like a management plane as a whole, right? So, and you can't just represent it as the several functions that deliver, an information digital twin function. So, I mean, yeah, I recognize there are these two sort of conceptions, and certainly that one is more restrictive. Simply pointing out that two have to be a little bit careful, because it's really a collection of functions, and it's not a single thing. And one could, in fact, represent them as, the new thing here is an information digital twin. Management planes that are automated, we can construct those as, the assembly of known things, intent renderers, closed loops, whatever it is, plus this new thing, a digital twin that provides information. That's a possibility. That's all I'm pointing out.
Sure.
Okay. Jordi?
Hi, hello. I hope you can hear me.
Yes.
Yeah, just to complement on Chris' answer to Sharon, our initial scope was rated on performance. So targeting lateral attack movements, it's not in our scope right now, Sharon. We were more thinking about how is the network performing. So are you having some delay at some link? Is there some jitter that is high as you would expect? And similar questions. However, it's an interesting aspect to consider also. I'll try to drop you a line later offline about this topic. And sorry, just another point regarding the previous discussion. The focus of that is saying, okay, what is a digital twin useful for? And from our perspective, we consider number two, as Alex was suggesting. I acknowledge and I agree that it's really interesting, but I think it's broadening too much the scope. So, because if you get a management plane, well, I have never operated a network except from my home network, and I think it's too simple. But I mean, everyone manages networks differently, and there are like tons of different ways to manage networks. So, from our perspective, it's a scope that is too broad. That's all. Thanks.
Okay, thank you, Jordi, for the ideas. Okay, so there is no other question. Thank Chris for the presentation. So let's move on. Next presentation. So Daniel?
Yes, Chair, can you hear me?
Yes, we can hear you.
Okay, this draft is about the requirements for interfaces of network digital twin. Next slide, please. And as defined in the active research group draft digital twin network concepts and reference architecture, the digital twin network is defined as a network system with a physical network entity and a virtual twin, and the two can interact with each other in real time. And DTN has the four core elements: data, model, mapping, interaction. So next slide, please. So based on the draft digital twin network concepts and reference architecture, the interfaces of digital twin network can be divided as the twin northbound interfaces, twin southbound interfaces, and internal interfaces. So in order to build a digital twin network and realize its many advantages, different interfaces should be able to meet different requirements. And this draft is to introduce the requirements for the interfaces of DTN. So the positions of different interfaces are shown in the figure on the right. So next slide, please. So for the requirements for twin northbound interfaces, the twin northbound interfaces is the interface between the network application layer and the twin network layer. So the network application requirements are input from the twin northbound interface to the twin network layer. So the twin northbound interfaces can support the rapid deployment of network applications such as the network operation and optimization, network visualization, intent verification, network automatic driving with lower cost, higher efficiency, and less impact on the live network services. So the twin northbound interfaces should have these characteristics, such as the first one is openness. The twin northbound interfaces must meet the business requirements of different network applications and can be input to the twin network layer. So it needs to have good openness and compatibility. And second is it should be scalability. So as we all know, there are a variety of network applications in the network application layer. So it will inevitably to lead to the generation of network applications. And the continuous development of the network is bound to introduce new network applications. So with the upgrade of network applications and the generation of new applications, the thin northbound interfaces should be able to expand in time to meet the needs of new network applications. And thirdly is that it should be portability. For there are things with different sizes and functions in the thin network layer. The same or similar requirements of various applications in the network application layer may be deployed on different things. So the twin northbound interface should be easily transplanted and deployed on different things. And last one is that it should be flexible deployment. To reduce deployment time and cost. So next slide, please. So as shown in the three domain double closed loop of DTN architecture, the thin network layer contains the three key subsystems: the data sharing warehouse, service mapping model, digital twin management. So it's the most critical part of the digital twin network. And the internal interface of the twin layer refers to the interface within and between the three subsystems. So in order to support the functions of the three subsystems in the twin network layer and the interaction between the three subsystems, the internal interface of the twin layer should have the following four functions. Firstly, it should be united. That each subsystem in the twin network layer should be able to provide the same data format and the data service for other subsystems through the internal interface of the twin layer. That is, the interface should have unity. And secondly is adaptability. For the twin network layer must interact with the network application layer and the physical network layer, and should be well adapted to various network devices and interfaces. It should be adaptability. So thirdly is that it should be portability. The data model instances provided by the service mapping model subsystem for different applications may have a high degree of similarities. So in order to improve efficiency, the data model instances must be able to be provided and deployed through different internal interfaces of twin layers. And the last one is flexible and extensible. The twin network layer must be able to verify different new network services. So in order to shorten the implementation time of functions, the implementation of functions inside the twin layer should be simplified as far as possible. Therefore, the internal interface of the twin network layer must be flexible and extensible. So next slide, please. And this slide is the requirements for twin southbound interface. And the twin southbound interface is referred to the interface between the twin network layer and the physical network layer. So control updates are delivered from the twin southbound interface to the physical entity network. And the various network elements in the physical entity network exchange network data and network control information with the network layer through the twin southbound interface. So the southbound chain interface should also have the characteristics as follows. First one is the information interaction capability. The twin southbound interface should be able to collect the information of different physical network elements or network devices and send the configuration information of the twin network to the physical network for execution. Each can realize the information interaction between the twin network layer and the physical entity network layer. And the second is the real-time requirements. The realization of twin network configuration, verification, and other functions must have certain real-time. So the information collected and uploaded from the physical entity network and the configuration information sent from the twin network to the physical network must have certain real-time in order to meet the real-time requirements of the whole digital twin network. And the next, the thirdly is the compatibility. So network devices and network elements from different manufacturers use different interfaces and protocols. The southbound interfaces must be compatible to ensure the reliability of information collection and the configuration delivery. So next slide, please. So for next slides, we plan to give some suggestions on the applicability of common protocols and add some security considerations. And that's all. Thanks.
Thank you, Yang. Any comment or question? Okay, I think, Daniel, as you recently proposed this new draft, this new contribution, I think people might need to have some time to read the document and provide you some feedback maybe on the mailing list. Thank you again for the presentation. I propose that we continue. There is no question now. Maybe on the chat there is one. Just let me check. Okay, looks like we should have discussion on interface to network digital twin from Laurent. Okay, yeah, between these regarding draft. Okay, thank you again. Let's move on with the next presentation from Alex.
So yes, hello everyone. So I'm going to present on challenges and opportunities in green networking. This is a follow-up on a presentation that we had also in Philadelphia. Next slide.
Sorry.
So again, so what is this about? So why green networking? Clearly, I think everybody's aware that reducing the carbon footprint to net zero is one of the grand challenges of mankind. And networking applications are, of course, a key enabler in this. However, the question is this enough? And also, networks themselves contribute basically to the carbon footprint. So hence the question, or hence basically I think the fact is that the net zero mandates will also apply to network providers as well. And so the question is, what can we do? What can IETF and IRTF contribute to those factors to reduce these items? And clearly, basically, a big factor are general hardware advances, deployment factors, and so on. We're not talking about those, but really basically about the things that we have an influence here. Next one. So so there's this draft CX Green PS01. The purpose is basically to analyze the challenges and opportunities in green networking and network management. We did present 00 in IETF115, but there are a number of updates here. For one, basically there are editorial refinements throughout. Also, the original draft was mostly about energy efficiency or energy usage efficiency. This has been updated to also emphasize energy sources and deployment aspects in general, not just the energy usage efficiency, as well as to include considerations for the manufacturing life cycle of the equipment that is used to implement these. There's also there are some changes in section 5.2, which was about traffic adaptation. It's actually generalized, also expanded to be about protocol optimization. We added possibility of convert channels to security considerations, and we have also a new contributor to the draft. Next one, please. So this was basically just a brief recap of what's in the draft of those who haven't read it. Basically, we are structuring the opportunity, challenge and opportunity space into 4 different aspects. On one hand, basically, we have the device and equipment level at the bottom. And there, as far as network management and IETF and IRTF challenges are concerned, we're focusing them mainly on the ability to provide visibility as a foundational problem that will essentially enable a lot of the other schemes and support that build it on top of them. And this is basically to assess the usage, assess and validate the effectiveness and efficiency, essentially of the energy usage and so forth. And this is then also the basis, of course, to enable later on control loops, for instance, for various optimization schemes, where you take various actions, for instance, to reduce the amount of carbon footprint, if you will, or, and want to, of course, validate and basically need to see the feedback of that. This requires also instrumentation for corresponding energy metrics. There is actually a companion draft on green networking metrics, which basically relates the metrics not just to equipment, but also to things such as flows and to paths and so forth, which are the types of things that we would want to optimize a network for and would want to optimize services for. Next one. So the second aspect concerns the network as a whole. So basically this concerns aspects such as challenges related to control protocol extensions, what would be needed to consider energy, sustainability and support as a cost factor in network control decisions, energy aware routing and path configuration, where you would have as one of the challenges, how can you assess the carbon intensity of paths if you have to choose between multiple ones? How do you optimize the network overall to minimize the overall footprint? Similarly, path-aware networking, steering traffic along greener paths. There have been also actually previous efforts in IETF regarding this. Resource weaning schemes. That's basically if you want to save energy, for instance, one of the fundamental ideas, of course, that you would want to turn off resources that may not be needed. But of course, in order to do so, you need to mitigate other operational goals, such as resilience, which you don't want to sacrifice as part of that. And so there are various challenges related to that, also related to this point, how would you, for instance, deploy and place virtual network functions in data centers and so forth. And then finally, basically, for the network as a whole, what are the green abstractions there, not just at the device level, but there, and also to take a holistic account, not just about the network, but also about the not just about the transmission, but about the processing, about the memory that's required, and so forth. Next one. Protocols. So this basically concerns challenges related to enabling network energy saving mechanisms. This blurs to some degrees the boundaries between management and control plane, because parts of the aspects are related to resource management. How can you, for instance, decommission resources on very short time scales? This requires mechanisms for fast discovery, what's going on in the network, fast reconvergence, and so forth. Clearly, there's a role for autonomics to play there, also for intent-based networking, where we had various use cases earlier. Other aspects concern network addressing, instrumentation, traffic adaptation. How can you manage perhaps the burstiness of the network versus smooth transitions to affect the energy transmission, and so forth. Next one. And then finally, basically at the architecture level, there's the question how you would facilitate the organization of categories networking applications that use the network to minimize energy consumption. And this concerns, well, there are examples such as, for instance, CDN, ICN, and COIN, which do some of those things, but basically the question is here, how is it from an energy perspective? So for instance, when would you deploy, we had this, would you for instance deploy cache information, what does that to the overall balance and so forth. Next one. So then basically the question to discuss here is basically how to move forward with this draft. And we believe actually that NMRG is a good landing spot for this. Many of the challenges, not all of them, but I think the majority of them are clearly management related. This includes, for instance, the starting point of the visibility and the instrumentation, the metrics and support, all of those things. And also, on top of that, basically many opportunities then involve management control loops and deployment optimizations. And these are fundamentally management-related problems and challenges. And there are, again, some of those examples there. How do you plan routes, segments, paths? How do you moderate the various trade-offs that you have, etc.? How do you optimize carbon footprint as one of the parameters in your network deployment? And this does involve actually many research-related questions that can also eventually lead to identify standardization opportunities. And it's our opinion that this makes IETF and NMRG an excellent candidate to position this work. Next slide, please. And so essentially the question to discuss here is this management for sustainability, for greenness, a topic that NMRG is taking on? And if so, how should we proceed with this draft? And there are two possibilities, basically to adopt this draft as it is, or to possibly also break out the management specifics from the overall question, because there's a few non-management related items also currently included in the draft. And so with this, I'd like to conclude and request feedback.
Thanks, Alex. As co-author of the draft, and I haven't updated it, but I would like to provide perspective from a very different point of view, urgency of this work. So traditionally, this kind of work was done as wishful thinking, or, we want to reduce OpEx and maybe make world better place. We are getting to the point that we cannot deploy anymore. If you look at how SerDes and silicon technology evolves, we double the speed every 2 years. So more law is still applicable, while power consumption goes down by half. So with each generation, so every 2 years, we double power consumption on each networking device we deployed. From size perspective, we are getting to 1.2 gigawatt data centers. So there's no infrastructure in the world that can actually power this kind of data center or cool them down. To provide you some comparison point, City of Dublin consumes 2 gigawatts. Microsoft data center 1.2. So we are getting close. So it's not only nice to have, we cannot really continue at the rate we go today. We really need to start looking into how to optimize. We need to reduce carbon emission. We need to reduce amount of electricity we use, because there's really no way forward. We are hitting 1.6 tera 2 years from now. And what's next? How do we cool it? How do we deploy it?
Thanks. Other questions?
Any comment, question? No.
Sorry, I took time because my knee is killing me. In general, I believe that this keeping this as a whole study of the concern is something that is a right way I will go. I will not separate it in different matters, and though I believe that basically what we're talking is a little bit similar to the questions that Chris was issuing before about this idea of the informational and action digital twin that are a general at the end. If you have an action digital twin, you're talking about a general management tool like AI or whatever. It's how you put this in the general management flow. Here, the question is precisely how we put energy information and how we prioritize energy data and energy related decisions with respect to the other goals of the network. Basically what we are adding here is a new dimension in what we have to manage, in the goals, and essentially in the goals that what we have to manage.
Objectives, yes.
So that's I'm making emphasis on this and how this would affect policies and how policies have to be expressed and enforced. I think that is the main question here, because nobody is going to deny the importance of these or the relevance for the future of networking and even the future of humankind. But the point here of what we should focus is precisely in this new dimension.
Right. So for those types of implications, if you will, on also existing and existing networks, this is basically part of the challenges and opportunities that we would want to precisely actually point out here. And some of them may be straightforward engineering type of things. Then basically, okay, then we don't need to talk about much from a research perspective, but some other things will be more closer to research.
Yeah, no, exactly. I'm precisely analyzing how this fine-grained policy, how we can assign the priorities, what is more desirable, optimizing bandwidth or optimizing immediate consumption, because at the end, everything has an energy cost, if you think about it. So this is, it's an interesting matter, and I think that it will be, as I said, the focus of the day.
Thanks.
Hi, Jordi from Qualcomm. So yeah, for I guess forever we've been sort of under this paradigm of over-provisioning the networks in a sense, right? That's sort of been the philosophy. And we as engineers have often, or many times, or all the time, been told, don't worry about optimizing. It's over-provision. So you have, bandwidth and so on. So maybe there's an element about changing the mindset and saying it's really important to design algorithms that are optimized and that actually try to do better than what we do. Designing to some extent, the internet is designed to run 30% utilization. So is that really when we talk about carbon footprint, is that really a principle to start from? And should we sort of also talk about the mindset, the philosophy of how we design networks? Should we try to do better than just aiming for, okay, let's over-provision?
Yeah. So, I think the point is also, of course, we don't want to just optimize for sustainability also, because then, okay, the optimization is just don't do networking, right? Just turn switch the whole thing up, don't bother with it. Clearly this is not the solution either. So clearly you basically need to mitigate and moderate between different goals which are conflicting. So basically it is kind of like a constraint-based problem, because the constraint is still that you need to, as far as resilience, your cause and service level requirements, as far as all of those things are concerned, of course, you need to retain those, but while also making sure that you do what you can there. And obviously, as always, between mitigating goals, and you have also the challenge of policies. For instance, where are you willing to make trade-offs? How do you mitigate between the trade-offs? How do you manage them, and so forth? So yeah, this is part of the challenges, exactly.
David Summers-Harris with Ruckton. I was wondering if it'd be useful to clarify the scope of the research, whether this is for a single operator, providing them with ways to optimize the energy consumption or sustainability of their own network, or if it's also including like interoperability between operators. So one operator attests, I have great sustainability in my network, so if you route through me, then you'll be green. Then how do you prove that? And it reminds me of, carbon credits, and governments and companies have bought them. It turns out that they didn't really help the planet at all. And they're now spending those credits on, making the planet dirty. So how do we have to address that as well? Is that in scope, or we just?
Right. So that's a great comment, actually. So clearly, in this draft, we are not restricted to one provider, but clearly some of the challenges are related to specific providers. Some are related to vendors. Some are basically for the holistic picture, which takes all of them into account. And obviously, some of the things, actually, the draft also makes mention of that. You could, for instance, say, well, as a network provider, I optimize just what I do in my network, and it doesn't matter what happens in the data center, for instance. And you could do that, but of course, then you shift perhaps the burden somewhere else. which helps you energy cost first, but which does not help the holistic picture. So clear, and clearly there are both of these pictures, and that's another, of course, of the challenges. How do we moderate between that? And yeah, for instance, also the aspect, yeah, how would you assess this? How do you check for compliance and so on? That is, these are all part of the things that will need to be addressed.
Last question.
Tim G, China Mobile here. The thing is, so far, if you look at the green topic, a lot of providers, it's not just the service provider, there are some like OTT companies talking about to recycle the waste, the heat waste, and like by using like a liquid cooling, and then from the hardware is going to heat up the water that's going to be recycled, used in the community. So that means if you look at your topic, so I agree this is a very interesting topic, and then I support it. The thing is here, if you consider those type of scenario, since this one is not a standalone, not just like that networking part, it's going to be impacted either one way or the other. So I don't know whether you have already considered, suppose you consider something is not green since it consumes a lot of energy. However, there is another scenario in place that's going to recycle those waste. Yeah. So the type of things. Thanks.
So this is one of the challenges. Is actually this one of the things which is in this newer draft. Actually, a little bit expanded on. Probably perhaps needs more expansion on. This concerns the fact that clearly for the holistic picture, it does include. For instance, you mentioned recycling the whole manufacturing life cycle. So from that perspective, it's certainly good if you can extend the lifetime, for instance, of your hardware by perhaps making more software-based, basically addressing through software upgrades versus relying on hardware upgrades and so on. The question is how to again manage that. Part of that may be when it comes to the metrics that you're trying to optimize. Well, you could have, for instance, sustainability metrics. How you verify, how you assess, how you make sure that they comply, one of those problems there. But you could, for instance, include that and basically then make that part of your overall optimization equation.
So going back to networking, I think we're looking into metric normalization, really. If you run an IPv6 network today, there are a number of components that will feed into PC computation and provide you either shortest lowest latency or lowest bandwidth maximum protection path, right? We don't include power consumption as computation parameter or constraint. So by having normalized metrics that could potentially come out of this work towards IETF, we could use it in normalized PC computation to compute a path that meets some power constraints. That would be very engineering focused work, and I mean we've been doing this idea for many years. IGP extension, BGP-less extension, so this work is being done for a long time.
Thank you. Thanks. We have to stop here for this. Just share with you a comment from Laurence that it's important to frame the problem in space and what NMRG can realistically address. So let's move on to last presentation by Nigel.
I knew I was in danger time-wise there when that such an important presentation was on before me, so I knew there'd be lots of questions. So I'm looking at this presentation's on modeling boundaries, and it's boundaries in modeling languages. It's actually a draft into NetMod, but I wanted to present here because I think there's some forward-looking stuff. You can do the next slide, please. So I won't go through the overview, just a couple of key points at the bottom there. I've been grappling with this for a long time, and it's clear there are issues in the modeling languages that make it difficult to deal with. So I'll explain the details. Next slide, please. So the draft actually has a number of observations of challenges in modeling, and it focuses a lot on modeling of representations that involve dealing with constraints. And I picked out a number of things here, all of which have got very similar requirements, intent, modeling of intent, of capability, expressing restrictions. I picked out one there, partial visibility, which is one that doesn't get much attention, but this is where I can't fully see the monitoring or the detectors in the network, and I have some partial view of that, which looks somewhat like constraints.
the process of negotiation where I move through from a fairly abstract and nebulous view of what I want through to a much more specific thing, but again, a set of constraints which leads to intent, of course. And all of these require some view of uncertainty, some view of vagueness, interrelated attributes and properties and so on, which have got constraints and interrelated constraints. The representation of these things progresses through a set of gradual narrowing. So especially in negotiation, I started with something fairly nebulous and I gradually narrow it down to a precise level. If I look at intent, I may have an intent that starts off as relatively vague and then becomes more refined as the implementation takes place. And there's a number of levels through this. It also applies as I look at, especially as I look at specification. I've got an example a little bit later of capability, where I move from a standard specification through a number of vendor restrictions and so on. I'll go through an example of that. These narrowings relate in what we've had to classify with a new term. There's a big terminology problem in this. It's proved to be difficult to actually discuss this space because of lacking terms. So we have classes, instances, and then we run out. So we coined this term in the ONF work of occurrence, which is a thing that's some way through the progression of narrowings of definition. And through this work, and certainly in the draft, we've looked at the opportunity to generalize classes and instances to form this occurrence thing. So I wanted to really get some feeling from the group as to whether this was interesting, whether other people were encountering similar things. And when the other thing is when I start building up a picture of a system definition, we see the same thing, assemblies of occurrences rather than instances and rather than classes. So I'll try and show an example of that. The assembly of a system, you get many similar but not identical occurrences where you're placing constraints on the behavior of a particular thing that narrows it from the class but doesn't make it into an instance. And this was the general problem. So the draft goes through these general sort of principles and so on, and it makes a number of observations in those areas. You go to the next slide, please. Thanks. So the solution, we need a modeling approach that allows us to better define these intermediate stages of this recursive narrowing. So we move from maybe a class through to some a number of different alternative views of that class that are narrowed slightly, that have restricted opportunities for attribute values and so on. But there may be several different restrictions in a particular problem situation. And then as we looked at this, we felt that any levelist model would end up with something that has definition of what look like types, but they're narrowed, and also definition of what look like instance values because there's a single fixed value. And what that essentially ends up with is any particular definition is a definition of a narrowed constraint, even if it's a single value. That's still a narrow constraint. So even a single, even an expression of an instance value is a constraint. So and that leads us to potentially a single way of expressing everything from classes all the way through to instances. The conventional modeling techniques we use tend to break it into those two things, a class or an instance. And we have those two sort of levels. We don't, I mean, all meta classes, but we don't have this gradual slide. And the property types we have, like integer, tend to emphasize that it's got a single value. Whereas if I'm monitoring something, I may find that sometimes I've got uncertainty in the measurement and I'm not sure whether it's 5, 6, or 7, but other times I've got a precise value. Sometimes I can't see it at all. So these sorts of things tend to push us towards a distinct way of representing compared to what we would traditionally do. And we found, as I've been through, as I mentioned, a long time challenging with this, as we go through the challenge, through the challenge of modeling particular problems, we found we had to put special attributes in to deal with these funny cases and so on, and you keep finding them. So I put this into NetMod because I felt that, or we felt that there was an opportunity in Yang itself to to extend the language to deal with these challenges. And we've got a proposal in the back of the, or a sketch of a proposal in the back of the draft that shows some of the things you could do potentially with Yang. And it would seem to be possible to extend it within its current definition so it's compatible with existing things, which I think is critical. So if you could go to the next slide, please. Thanks. So just to get the things here, just to emphasize, so intent in the draft, I use expectation intention rather than intent, really, because there's two sides of that. There's the client side expects stuff, and the provider side intends to deal with a thing. But that's desired outcome in terms of constraints, just to emphasize that. Capability is about opportunity for behavior to be exhibited, and that, of course, is again a range of possible restrictions and constraints. And the partial visibility, as I said, is imprecise measurements in a lossy or environment where I've got a challenge with noise or something of this sort, where I can't actually see fully what's going on. If you go to the next slide, please. Thanks. So this is just to emphasize this gradual progression or narrowing. It's obviously an arbitrary sort of rough example, but I may start with a standard definition of something where I've got an integer. It's boundless, essentially. It's the full range of the integer. It's specified in Hertz, no constraints whatsoever. I find I have two particular implementations that a vendor has, where in one it's got arbitrarily chosen here, of course, 10 gigs to 100 gigs or something. Another one's got 5 to 50, where there's some constraints in the particular technology. So I've got two different realizations in my particular solution. Here I want to be able to express those two different capabilities. Then in an application, I only need 10 to 50 gigs. I want to be able to express that constraint. I have a further point maybe in the application where it's at a particular point in the solution, there's a specific restriction on the range, so it's only 30 to 50 gigs, a particular place, same implementation hardware and so on, but a particular place. And in a proof of concept, if I've got some busy hour thing, I'll say it's always 50 gigs. So I've got these different levels of setting for this property, and I want to be able to set ranges and signal values in the property. And again, other examples, proof of concept, different narrowing, and maybe it's turned into an enumeration because I've only got 3 proof points I'm going for. And when I look at the instance at the bottom there, I've got an intent instance. One, the intent is set to 30 or 40. Another one is set to specifically 40. So I've got different ways of constraining this very simple property, and I've got various different occurrences of these constraints in the solution space. This is just trying to illustrate the sort of range of narrowing from a standard through a number of different cases where they're each expressions of the same property. They're each expressions of the integer, but they're expressions of the integer in terms of different narrows. If you go to the next slide, please. So I'm not going to go through this in detail, but the draft does, but the key thing here is I've assembled the system out of the same pieces, the brown pieces here with the same letters on the same pieces, but each is being used in a certainly different role, and each is being used in a way where it's constrained to perform a different function. It's the same underlying thing, but the specification for it is constrained, and each of those things in that figure are essentially occurrences because they're not instances because I haven't instantiated them, they're just in the pattern. So the occurrence here is a pattern tool as well here, essentially, that lets me lay out different cases of use of a particular single thing in a system design. And this actually is a sketch of a management hierarchy, abstracting signals from the ONF work, abstracting from a network view to a nodal view to a network view. If you do the next slide, please. I think I'm going to skip the next one. Yeah, I'll skip this one actually because it's detail on the slide. And the key thing here for the first thing is we've had terminology problems trying to discuss this and so on. So getting a better view of the terminology, the labels we use in the problem spaces. We chose the term occurrence because it appeared to be something that wasn't being used, and it did appear to sort of emphasize the instance-like nature of this thing, but not an instance. There's not a good language for this again, so representing it, or there doesn't appear to be. We can't find a language that seems, so UML has classes and instances. Yang has the same sort of two positions and so on. There don't seem to be any language that give us this gradual slide from a vague notion through to a very specific definition. So we're continuing to explore. We haven't found anything. Looking again to the group to see if anybody's aware of anything that does this sort of that represents this sort of thing well. And as I said, into NetMod, because we feel that Yang could be extended in this way, then into this direction, and we felt that this was a good input into NetMod. So that's all I had. I've got some backup slides, which I won't do now. Obviously, there's some stuff in the draft, which hopefully you could read and maybe give some feedback on.
Thank you. Thank you, Nigel. Unfortunately, we are at the end of the time of the meeting. I'm sorry for that. So maybe the best would be that people can send comments or questions offline.
Yeah.
And of course, also follow your work in NetMod. But very thank you for.
Okay. I'm also here, of course, for a while. So if people want, we can sort of discuss
over
the break.
Of course, yes. Yeah, sure. So, okay. Thank you again, Nigel.
Thank you.
And thank you all on site and online for having joined this meeting. And so we'll, as usual, share the minutes. And thank you again. And see you or talk to you soon. Bye-bye. Just in time? No time for question. Yeah, but for the question, yeah. Ah. Thank you. So you take notes with Laurent? Okay. It's not always easy. Okay.
In the assessment, we are in the group in different areas. So we are